Hello everyone, welcome to EPT classes. Today we are going to start class 10 chapter 8 introduction to trigonometry. It's exercise 8.3. Now let's start. The first one question is express the trigonometric ratios sin A, sec A and tan A in terms of cot A. So first of all we'll write sin A, sec A, tan A in terms of cot A. So here sin A, we know that one, we have to change that one to cot A. So first of all sin A we can change 1 upon cosec A. We know that one, sin theta equal to 1 upon cosec theta. So 1 upon cosec A. It's also here we can write 1 upon cosec theta. We know that one formula is there, one identity, cosec square theta minus cot square theta equal to 1. So only cosec theta, cosec square theta equal to 1 plus cot square theta. So here cosec theta we can write 1 plus cot square theta, its square root. So instead of cosec A we can write 1 plus cot square A, its square root. Now look at here, sin A it changes to cot A. Okay. Second one is sec A. Sec A we have to change also cot A. How to change sec A to cot A? First of all we know one identity is sec square theta minus tan square theta equal to 1. So if sec square theta minus tan square theta equal to 1, we can write sec square theta equal to 1 plus tan square theta. And if sec square theta equal to 1 plus tan square theta, then sec theta equal to 1 plus tan square theta, its square root. So here we can write also sec theta or sec A equal to 1 plus tan square A, its square root. Okay. And tan, we know that one, tan equal to 1 upon cot. So we can write here 1 plus tan square A. Instead of that we can write 1 upon cot square A, its square root. Now if we take the LCM, here nothing is there, that means 1 and cot square A, the LCM is cot square A. If we take the LCM, then cot square A divided by 1, the result is cot square A into 1 equal to cot square A plus cot square A cancel with cot square A, that will be divided 1 into 1 equal to 1, its square root. Now 1 plus cot square A, its square root upon cot square A square root. Cot square A square root means cot A into cot A. So we can cancel root over sine and we can write cot A. Okay. So this is also transfer sec A to cot A. Now tan A to cot A. Tan A to cot A we know that is very easy. Tan A, that formula is 1 upon cot A. So we can write here 1 upon cot A. This is the first one question. Let's start the second one. The second one question is write all the other trigonometric ratios of angle A in terms of sec A. This one is angle A. Okay, in terms of sec A. So trigonometric ratios. So we know that one, trigonometric ratios are sin A, cos A, tan A, cot A, sec A and cosec A. So these all are the trigonometric ratio. We have to change all the trigonometric ratio of angle A. So everywhere I have written angle A, instead of that theta or instead of that B, C, whatever the value we can write. But question is given angle A in terms of sec A. So we need to change all these trigonometric value in terms of sec A. So sin 2 is changed to sec A. How we can change sin to sec? First of all, sin, we can write sin in the form. Let's see. Cos A we can easily change to sec A, because cos A we know that one, that is 1 upon sec A. Directly we can change cos A equal to 1 upon sec A. Tan A also we can change easily, because tan A value is sec square theta minus tan square theta, the value is 1. So tan A equal to 1. Look at here. Suppose I want to write here. Now check it. Sec square A minus tan square A. the result is 1. So if you write tan square a, what will be the value? That will be sec square a minus 1. Okay, so tan a equal to its root over, its square root of this number. So its root over will be tan a value. Now tan a equal to, we can write here sec square a minus 1 its root over, that is tan a. Okay, cot a, we know that one, that is the inverse of tan a. That means cot a equal to 1 upon tan a. So instead of tan a, the value is, we already know that one, sec square a minus 1. We'll write 1 upon sec square a minus 1 its root over. Okay, now look at this point, sin a, and another one left is cosec a. Now write down here cosec a. Cosec a, we have to change sec a, and sin a also we have to change sec a. So here sin a, how we can change to sec a? There is one formula, you know that sin square a, one identity is there, sin square a plus cos square a, the result is 1. We know that one, sin square a plus cos square a equal to 1. So here if I take sin a, sin a will be, cos square a will change to that side, it will be 1 minus cos square a its square root. Cos, we know that one, how to change that sec, cos equal to 1 upon sec equal to cos theta. So we can write here 1 minus 1 upon sec square a its root over. Yes, so here look at that, here nothing is there in the denominator, 1 and sec square a, the LCM is sec square a, and sec square a divided by 1, that is sec square a into 1 equal to sec square a, and sec square divided by sec square a, denominator will divide 1, numerator will multiply 1 into 1, the result is 1, its root over. Now we can write here sec square a minus 1 its square root, but in the denominator sec square is there, its square root is sec a. So we have changed sin a to, this one is total sec a. So we can write here sec square a minus 1 upon sec a. So here only the square root on the numerator. Okay. Now the last one is cosec a. Cosec a equal to 1 upon sin a. We know the formula of cosec a equal to 1 upon sin a. So instead of sin a, we have already sec value. So we can write here 1 upon sec a value, sec, that sign changes to sec a, the value is root over of sec square a minus 1 upon sec a. So if we change fraction divided by another fraction, so what we can write here, 1 into numerator changes to denominator, denominator changes to numerator. So it will be sec a upon root over of sec square minus 1. So answer is sec a upon square root of sec square a minus 1. Okay, let's come to question number 3. Now question number 3. Choose the correct option, justify your choice. 9 sec square a minus 9 tan square a. What will be the value out of these 4 options? We know that one, 9 sec square a minus 9 tan square a. Here, which one is common first? The common is 9. If we take common 9, the value is sec square a minus tan square a. Okay, we know one trigonometric identities, the formula is sec square theta minus tan square theta, the result is 1. So instead of theta here a is written, we can write 9 into sec square a minus tan square, the result is 1. So answer will be 9. So option B is the correct answer. Next one, 1 plus tan theta plus sec theta whole bracket into 1 plus cot theta minus cosec theta equal to dash. So first of all, check that 1 plus, instead of tan theta we can write sin theta upon cos theta. Okay, and sec theta we write 1 upon cos theta, then multiplied by 1 plus cot theta. Cot theta we can write cos theta upon sin theta, and cosec theta we can write 1 upon sin theta. Why we change that one? Because here look at this, the denominator is equal and here also denominator is equal. Now we can take LCM easily. Look at here, cos theta, what is the LCM? Cos theta. And numerator part will be cos theta divided by nothing is there, that means 1, divided by 1 and numerator will multiply. So value is cos theta divided by cos theta 1 into sin theta, the result is sin theta, then plus 1. Similarly, that side sin theta is the LCM. Sin theta is the LCM means then we can take sin theta plus cos theta minus 1. Okay. Now here check it, sin theta cos theta plus sin theta, we can write sin theta plus cos theta plus 1. Here is sin theta plus cos theta minus 1. If you multiply both these, suppose if you take this one is a, suppose this one is total a and this one is b, let us see, a plus b, a minus b. What is the formula? A square minus b square. So I am writing here sin theta plus cos theta, a square, that means a we have taken, let sin theta plus cos theta is a, so a square minus, because a plus this one is b, this one is a minus b, a square minus b square, b is 1, so minus b square upon cos theta and sin theta. If you multiply, the result is sin theta into cos theta. Okay. Now a plus a square minus b square. So here also you can check, this one is suppose x plus y whole square. X plus y whole square means s square, that means sin square theta, plus y square, that is cos square theta, and plus 2ab. 2ab means 2 sin theta into cos theta. Then minus 1 square is 1 upon sin theta into cos theta. Sin theta into cos theta. Now sin square theta plus cos square theta, what is the value? We know sin square theta plus cos square theta. Now look at here, sin square theta plus cos square theta, the value is 1 plus 2 sin theta into cos theta minus 1 divided by sin theta into cos theta. Now 1 minus 1 cancel. Okay. What's left on the numerator? 2 sin theta into cos theta upon denominator is sin theta into cos theta. So this one sin theta into cos theta, sin theta into cos theta multiplication, it's cancelled. What's left? The value is 2. 2 is the answer. So option C is the correct answer. Okay. Next, here bit number 3 is sec a plus tan a into 1 minus sin a. What will be the answer? Sec a, we can write sec a equal to 1 upon cos a. Direct I am writing sec a equal to 1 upon cos a plus tan a equal to sin a upon cos a. Okay, and it's multiplied by 1 minus sin a. Let's see, don't change that one, write down 1 minus sin a. Whatever is there, write down, and nothing is there means denominator is 1. If you will multiply both these, now first of all we will take the LCM. Cos a, what is the LCM? LCM is cos a, and upper part numerator is 1 plus sin a. Then it's multiplied by 1 minus sin a. Let's write here 1 minus sin a. Now you can check, the denominator is cos a, numerator is 1 plus sin a into 1 minus sin a, that is a plus b into a minus b. The identity is a square minus b square. So 1 square minus sin a its whole square upon cos a. So now you can take 1 square is 1 minus sin a its whole square is sin square a upon cos a. 1 minus sin square A, the result is cos square A divided by cos A. Cos square A divided by cos A means cos A, it will be cancelled, the result is cos A. So answer is option D is the correct answer. Okay. Then the bit number 4, 1 plus tan square A divided by 1 plus cot square A. Now tell me, 1 plus tan square A divided by 1 plus cot square A, if you write 1 plus tan square A, what is the value? That is sec square A. 1 plus tan square A equal to sec square A, because sec square theta minus tan square theta equal to 1. So 1 plus tan square A equal to sec square A divided by 1 plus cot square A. Direct identity, cosec square A minus cot square A equal to 1. So 1 plus cot square A, the result is cosec square A. Sec square A value is 1 upon cos square A. Cosec square A value is 1 upon sin square A. Because cosec theta is 1 upon sin theta, cos square A will be 1 upon sin square A. 1 upon cos square A, we can write here 1 upon cos square A, and this fraction changes, then denominator will changes to numerator, sin square A upon 1. 1 cancel, the result is sin square A upon cos square A. Sin square A upon cos square A, the value is tan square A. So tan square is the option number D is the correct answer. Next, question number 4. Cosec theta, we have to prove LHS equal to RHS. So here we'll write first cosec theta minus cot theta its whole square. Cosec theta, LHS side, it is cosec theta. Cosec theta we can write 1 upon sin theta. 1 upon sin theta minus cot theta equal to cos theta upon sin theta, its whole square. Now here LCM is sin theta, we can take LCM sin theta, and here 1 minus cos theta, its whole square. Now look at here, we have to change that one. RHS side 1 minus cos theta and 1 plus cos theta is there. We need to prove that. So according to that, 1 minus cos theta whole square, we can write numerator 1 minus cos theta its whole square, and denominator is sin theta its whole square, means sin square theta. Okay. Now we'll start writing here 1 minus cos theta its whole square means if a square is there, a into a. So similarly 1 minus cos theta means we can write 1 minus cos theta into 1 minus cos theta. Okay. After that, sin square theta, we know that one, sin square theta equal to 1 minus cos square theta. Yes. So now look at here, it's like a square minus b square. So we can write here 1 minus cos theta into 1 minus cos theta upon 1 minus cos square theta. That means a square minus b square means a plus b into a minus b. Okay, a minus b cancel. Then what's left? 1 minus cos theta upon 1 plus cos theta. That is the RHS. So LHS equal to RHS, proved. Then LHS. LHS is cos A upon 1 plus sin A, and there is plus 1 plus sin A divided by cos A. So here LCM is 1 plus sin A, 1 plus sin A into cos A. That is the LCM. So if you write this one is the LCM, we know that one 1 plus sin A, if you cut, the result will be cos A. So denominator will be cancelled, numerator will multiply, denominator will divide, numerator will multiply. If you divide, 1 plus sin A will be cancelled, cos A into cos A. What is the answer? Cos square A. Plus here cos A will be cancelled, 1 plus sin A into 1 plus sin A, the result will be 1 plus sin A its whole square. Now cos square A plus 1 plus sin a its whole square means 1 square plus sin a its whole square means sin square a plus b whole square formula. A square plus b square plus 2ab plus 2 into 1 into sin a divided by 1 plus sin a into cos a. So we can write cos a into 1 plus sin a. Okay. Now cos square a and sin square a, if we add, the result is 1. Here I am writing cos square a plus sin square a, the result is 1. And 1 square is also 1. Then what's left? 2 into sin a, the result is 2 sin a. Numerator clear? Then denominator cos a into 1 plus sin a. We write like this, cos a into 1 plus sin a. Now on the numerator 1 plus 1, what is the answer? 2. 2 plus 2 sin a. 2 plus 2 sin a divided by cos a into whole bracket of 1 plus sin a. Then if we take common here 2, if we take common here 2, the result will be 1 plus sin a divided by cos a into, that will be 1 plus sin a. We need to find out in RHS 2 into sec a. So here numerator denominator cancel. 2 upon cos a. 2 upon cos a means, can we write 2 upon cos a means 2 into 1 upon cos a? Yes. So 1 upon cos a, we know that one, that is sec a. 2 sec a. That is the RHS. Okay. Next, the question number 3. Bit number 3. Tan theta upon 1 minus cot theta. So we can write tan theta, LHS side, writing tan theta equal to sin theta upon cos theta. And 1 minus cot theta, we can write cot theta equal to cos theta upon sin theta. Then that side, cot theta equal to, we can write cos theta upon sin theta divided by 1 minus tan theta, we can write 1 minus sin theta upon cos theta. Then sin theta upon cos theta, we'll write like this, sin theta upon cos theta, and this one is in denominator 1 minus cos theta upon sin theta. So we can write sin theta is the LCM, and this one will be sin theta minus cos theta plus here cos theta upon sin theta whole divided by here cos theta is the LCM, and this one will be cos theta minus sin theta. Fraction divided by another fraction means we can write like this, the sin theta upon cos theta, and here denominator changes to numerator and numerator changes to denominator. Okay. And look at here, it's important thing, cos theta upon sin theta. Now check it here, sin theta minus cos theta is there, but here is cos theta minus sin theta. If we change, then numerator changes to denominator, so cos theta upon cos theta minus sin theta. Here sin theta minus cos theta, there is cos theta minus sin theta. So we know that one. Suppose a minus b is there. If I want to change that one to b minus a, if we multiply here minus, then it will be equal to a minus b. Yes or no? Suppose a minus b is here. If I multiply minus with b minus a, that means minus into b minus b, minus into minus, that will be plus a. So this one is equal to this. So similarly, if I can write here cos theta minus sin theta, instead of that I am writing sin theta minus cos theta, sin theta minus cos theta, but here I write sin theta minus cos theta, but here I write one minus symbol. Which symbol I write? Minus. Because cos theta minus sin theta was there, I have written minus into sin theta minus cos theta. That is same. Now this is the multiplication. Okay. Now sin theta into sin theta. What is the answer? Sin square theta. And here you can check. Denominator is sin theta minus cos theta. Here is also sin theta minus cos theta. Can I take common here also? Yes, we can take common. Let's see first. Sin square theta cos theta into sin theta minus cos theta plus will changes to minus, because minus multiplied means it will become minus cos theta into cos theta, it is cos square theta upon sin theta into sin theta minus cos theta. Okay, now minus is there, minus on the denominator, it will change to numerator, so it will be plus changes to minus. Now here sin square theta, and this one is, you just check sin theta minus cos theta, there is sin theta minus cos theta, so we can take common 1 upon sin theta minus cos theta. If we take common this, what's left? Upper one numerator part is sin square theta, we'll write sin square theta, and denominator part is, that is cos theta. So cos theta, and here in between that minus symbol is there, minus, and here cos square theta upon sin theta. So cos square theta upon sin theta. Now 1 upon sin theta minus cos theta, and this one is cos theta sin theta, LCM is sin theta into cos theta, and here cos theta will be cancelled, sin theta into sin square theta, the result is sin q theta, minus here it will be also cos q theta. There is another one identities, algebraic identity is that aq minus bq. The formula is a minus b. So let's check sin theta minus cos theta, and here the formula is aq minus bq. The formula is a minus b. A is sin theta minus b is cos theta into a square, that means sin theta its whole square, that means sin square theta, plus ab. Ab means sin theta into cos theta, plus b square. B is cos theta its whole square, so cos square theta. Direct I have written here cos square theta. Now its denominator is sin theta into cos theta. That is the identities. Which identities? aq minus bq. A minus b into a square plus ab plus b square. Now 1 upon sin theta minus cos theta, and here a minus b sin theta minus cos theta into sin square theta plus cos square theta, the value is 1 plus sin theta into cos theta. Then denominator is sin theta into cos theta. Now these all numbers are multiplied with each other, so we can check here sin theta minus cos theta, here sin theta minus cos theta. Multiplication it will be cancelled. What's left? Numerator part is 1 into 1 plus sin theta into cos theta. The result is 1 plus sin theta into cos theta upon denominator is nothing is there, so sin theta into cos theta, sin theta into cos theta. Now look at here, suppose there is a number a plus b upon b, that means a upon b plus b upon b. Similarly we can write here 1 upon sin theta into cos theta plus sin theta into cos theta upon sin theta into cos theta, sin theta into cos theta. 1 upon sin theta into cos theta, because this one will be cancelled, sin theta upon cos theta, sin theta into cos theta, sin theta into cos theta, it will be cancelled. What's the answer? 1 plus here 1 upon sin theta into cos theta means 1 upon sin is cosec theta, 1 upon cos is sec theta, so that is the answer, sec theta into cosec theta, sec theta into cosec theta. That is the RHS. Okay, so LHS to RHS. So bit number 4, LHS is 1 plus sec a upon sec a. So 1 plus sec a upon sec a. We need to prove RHS side sin square a upon 1 minus cos a. So here sec a we can write 1 plus 1 upon cos a. And here also sec a is there 1 upon cos a. What is the LCM here? Numerator part, nothing is there 1. So cos a and n is cos a is the LCM. Upper one is cos a plus 1. I can write 1 plus cos a. No problem. Divide by 1 upon cos a. So no need to divide. Direct we can multiply. It will be cos a upon 1. So result is 1 cos a cancel. Cos a cancel. The result is 1 plus cos a is the answer. And here we'll check the RHS side. If you check the RHS side, this one is the last LHS answer. Now if you check RHS, sin square a, we can write 1 minus cos square a. Sin square a equal to 1 minus cos square a. Divide by 1 minus cos a. So 1 minus cos square a, that means a square minus b square, a plus b into a minus b, because that is the identity. Divide by 1 minus cos a. Now look at here, numerator 1 minus cos a, denominator 1 minus cos a. Cancel. What's left? 1 plus cos a. So LHS answer is 1 plus cos a, RHS answer is 1 plus cos a. So we can write LHS equal to RHS. Proved. LHS equal to RHS. Proved. Okay. Now next one, bit number 5. Cos a minus sin a plus 1 upon cos a plus sin a minus 1 equal to cosec a plus cot a. First of all, we have to check, is that written sec a or tan a or cosec, cot, whatever written. Here there is written cosec and cot. So cosec and cot means if we divide cos by sin, it will be cot. Sin by sin equal to 1. 1 upon sin, it will be cosec. So first of all, we'll divide everywhere sin a. So LHS side, we'll divide first cos a upon sin a. Why we will divide sin a? Because RHS side we need to prove cot a, and here is also cosec a. So for that reason we will divide first sin a everywhere, cos a upon sin a, minus sin a upon sin a. If we divide, then everywhere we will divide each and every term. On the numerator we will divide sin, and denominator also we will divide sin. Cos a upon sin a plus sin a upon sin a, then minus 1 upon sin a. Then cos upon sin, the answer is cot a. Minus sin upon sin, the result is 1. 1 upon sin, the result is cosec a. Divided by cos upon sin, what is the result? Cos upon sin, the result is cot a, plus sin a upon sin a, the result is 1, minus 1 upon sin a is cosec a. Now we have to cancel that one value. We can write here cot and cosec. According to that, one value will change, or here also one value will change. My point is that what is there in RHS? RHS, the numerator is cosec a plus cot a. So change the numerator only. What will change? Numerator only will change. So what is there? Cosec a plus cot a. We can write cosec a plus cot a minus 1. Instead of 1, we can write cosec square a minus cot square a. Why we write cosec square a minus cot square a? Because each and every identities are, look at here, each and every identities are cosec and cot. So instead of 1, we will write like this. After that, denominator will not change. We will write simply the denominator is 1 plus cot a minus cosec a. Whatever written, that same thing I have written here. Now look at here, cosec a, numerator cosec a plus cot a, and this one is minus cosec square a minus cot square a. So minus you can write here a square minus b square. The identity is a plus b into a minus b. So cosec a plus cot a into cosec a minus cot a. Okay, and denominator as equal to the same denominator will write 1 plus cot A minus cosec A. Now, what is there? Cosec A plus cot A, and after minus symbol cosec A plus cot A into cosec A minus cot A. So here is this one is one term, this one is one term. So two terms are there. In between two terms, cosec A plus cot A is common. So we can take common. After this, we can take common cosec A plus cot A. If we take common cosec A plus cot A, what's left? Here cosec A plus cot A taken common means 1 is left, 1 minus. Minus symbol is there. Cosec A plus cot A taken common. What's left? Cosec A minus cot A. So in bracket we will write cosec A minus cot A. So that will be in bracket. Then curly bracket upon this one is 1 plus cot A minus cosec A. As it is, the denominator is same. Now, offer one part, numerator, cosec A plus cot A. It's one part, one term into, multiply with, minus symbol is there, there is bracket. If you open the bracket, then it will be 1 minus, minus into cosec A minus cosec A, minus into minus cot A, negative, negative, multiplied with that will be plus cot A. And denominator as equal to same 1 plus cot A minus cosec A. Now check the numerator and denominator. These two are equal. That is multiplication. We can cancel. The result is cosec A plus cot A. That is the RHS part. So this one is RHS and proved. This one proved. Next, bit number 6, LHS. That is there, 1 plus sin A into 1 minus sin A. 1 plus sin A upon 1 minus sin A, its square root. So if this type question is there, you have to do like this, 1 plus sin A. Upper part is 1 plus sin A, numerator, and denominator is 1 minus sin A. If denominator is 1 minus sin A, multiply 1 plus sin A. According to that, if you have multiplied 1 plus sin A on the denominator, numerator should be multiplied 1 plus sin A. If suppose A plus B is there, then A minus B will multiply. If A minus B is there, then A plus B multiply. As denominator, if we multiply 1 plus sin A, numerator should be 1 plus sin A. Now, A plus B into A plus B. Formula is 1 plus sin A, its whole square upon 1 minus sin A into 1 plus sin A minus B into A plus B, A square minus B square. B square is sin square A, its root over. Any number its square its root over means the value is 1 plus sin A. Like that, A square its root over, that will be A. So 1 plus sin A its whole square, its root over means 1 plus sin A its whole square. We'll write first, after that we'll change. 1 square minus sin square A, that is 1 minus sin square A, it is cos square A, its square root. So its square its root over means direct we can write 1 plus sin A upon cos square A, its root over means it is cos A. So 1 plus sin A upon cos A equal to 1 upon cos A plus sin A upon cos A. So 1 upon cos A, the result is sec A plus sin A upon cos A equal to tan A. That is the RHS. That is the RHS proved, sec A plus tan A. Next, bit number 7. Here is the LHS side, sin theta minus 2 sin q theta upon 2 cos q theta minus cos theta. So here check the numerator, sin theta is common. If we take common sin theta, then result is 1 minus 2 sin square theta upon. Here if we take common cos theta, the result is 2 cos square theta minus 1. Okay. Now let's see, we need to find out RHS equal to tan theta. Then sin theta 1 minus 2 sin square theta, we can write 1 minus sin square theta minus sin square theta. 2 sin square theta I can written minus sin square theta minus sin square theta upon cos theta is same, and this one is 2 cos square theta minus 1. So Can we write cos square theta plus cos square theta minus 1? 2 cos square theta means cos square theta plus cos square theta minus 1. After that, sin theta into 1 minus sin square theta. What is the answer? 1 minus sin square theta, that is cos square theta. This one minus, as it is same, sin square theta upon divided by cos theta into cos square theta, whatever written, write down cos square theta minus 1, sin square theta plus cos square theta equal to 1. That is our identity. If cos square theta minus 1, then sin square theta change to RHS side, it will be minus sin square theta. So instead of cos square theta minus 1, we can write that will be minus sin square theta. Now check numerator and denominator, same, so it's cancelled. Now what's left? Sin theta upon cos theta. Sin theta upon cos theta is tan theta. That is the RHS. That is the RHS. Now, bit number 8. Sin A plus cosec A its whole square, cos A plus sec A its whole square. We need to find in RHS 7 plus tan square A plus cot square A. Sin A plus cosec A its whole square. We can write LHS side sin A plus B whole square, sin square A plus cosec square A plus 2 sin A into cosec A. Yes, after that there is a plus cos A plus sec A its whole square, that is also A plus B whole square, cos square A plus sec square A square plus B square plus 2AB, 2 cos A into sec A. Now look at here. Here is sin square A. We can write sin square A. There is cos square A. Write down here sin square A plus cos square A, because we know sin square A plus cos square A equal to 1. After that, cosec square A. Write down cosec square A. And here is 2 sin A into cosec A. What is that? 2 sin A into cosec A means we know cosec A equal to 1 upon sin A. So we can write 2 sin A into 1 upon sin A. And here sec square A, write down sec square A, no problem. And here cos A into sec A, will write 2 cos A into sec A equal to 1 upon cos A. Possible? Now, sin square A plus cos square A, the result is 1 plus cosec square A. We can change cosec square A equal to 1 plus cot square A, because we need to find out RHS side cot square A and tan square A. So cosec square theta we can write 1 plus cot square A, 1 plus cot square A. Then plus here sin A cancel, 2 into 1, that is 2, plus sec square A I can write 1 plus tan square A, because cot and tan, so we have to change sec to tan, cosec to cot. Over. Then cos A cancel, 2 into 1, the result is 2. Okay. Now check it. 1 plus 1 2, 2 plus 2 4, 4 plus 1 5, plus 2 7. So 7 plus tan square A plus cot square A. So this is the RHS. Okay. Good. Next, bit number 9. So LHS, that is cosec A minus sin A, sec A minus cos A. If we multiply, we have to find out RHS side 1 by tan A plus cot A. So here cosec A minus sin A, we can write cosec A equal to 1 upon sin A minus sin A, as it is sin A, write down that sin A upon 1, no problem. Sec A 1 upon cos A minus, here it is cos A. Okay. Now LCM is sin A, upper part is sin A divided by sin A, 1 into 1 1, minus sin A divided by 1 sin A into sin A, it will be sin square A. And this side cos A is the LCM, upper part will be same, 1 minus cos A into cos A equal to cos square A. Now tell me 1 minus sin square A, what is the formula? Cos square A upon sin A into, here 1 minus cos square A, it is sin square A upon cos A. So 1 cos A cancel, that will be cos A, Sin A, sin square A cancel, it will be sin A. So cos A into sin A. So cos A into sin A. Cos A, now this is not RHS, so we have to change cos A and sin A in terms of tan and cot. So cos A, here we have to check RHS, that one, if you change RHS equal to this also, that will be same. RHS is 1 upon tan A plus cot A. Instead of tan A, we can write sin A upon cos A, plus instead of cot A, we can write cos A upon sin A. Now check the denominator, and its LCM is cos A into sin A. If the denominator LCM is cos A into sin A, upper part cos A will be cancelled, sin A into sin A, it will be sin square A, plus here sin A cancel, cos A into cos A, it will be cos square A. So already we know that one fraction divided by fraction, that will be multiplied. 1 into upper denominator changes to numerator, it will be cos A into sin A divided by sin square A plus cos square A. Sin square A plus cos square A. We know sin square A plus cos square A, the value is 1. Sin square A plus cos square A, the value is 1. So 1 into cos A into sin A, that will be cos A into sin A upon 1. Sin square A plus cos square A, the value is 1. 1 means nothing is there. So it will be cos A into sin A. So now check the LHS side is cos A into sin A, and RHS is also cos A into sin A. So here we will write LHS equal to RHS. Proved. LHS equal to RHS. Okay. Now last one, bit number 10. 1 plus tan square A by 1 plus cot square A equal to this, equal to that. That means we have to find out this one equal to that, and this one also equal to this. So first first one side, 1 plus tan square A upon 1 plus cot square A. We know that one, tan square equal to sin upon cos. So 1 plus sin square A upon cos square A. Similarly, cot square A, we know that one, cos upon sin. So it will be cos square A upon sin square A. Okay. So here LCM is cos square A, numerator LCM is cos square A. We'll write here cos square A, and that will be cos square A plus sin square A. And denominator, it is sin square A LCM, and upper part will be sin square A plus cos square A. Now look at this, fraction divided by that fraction, then it will multiply, we know that one. So cos square A plus sin square A, the value is 1 upon cos square A, and if you change, sin square A will come to numerator, upon denominator is sin square A plus cos square A, it is also 1. So 1 cancel, the result is sin square A upon cos square A. Sin square upon cos square A, we know the value is tan square A. Is it that last one proved? Okay, the first one bit proved. Second one is there, 1 minus tan A. Now second one we need to prove with tan square A. 1 minus tan A its whole square. Tan A, instead of that we can write sin A upon cos A. Yes, this one, 1 minus sin A upon cos A divided by 1 minus cot A, we can write cos A upon sin A, its whole square. Now tell me, cos A LCM is cos A, upper part will be 1 minus sin A, sorry, it will not 1 minus, because cos A is the LCM, means nothing is there, means 1, cos A divided by 1 cos A into 1, it will be cos A minus sin A. Lower part is the denominator, that is sin A is the LCM, and it will be sin A minus cos A, its whole square. Now come to this. Here we can write cos A minus sin A, and there is sin A minus cos A. We know that one. Cos A minus sin A, fraction divided by fraction means we write here cos A, it will change into sin A upon sin A minus cos A. Sin A minus cos A, its whole square. Now, the very important thing, cos A minus sin A, and here is sin A minus cos A. Already I have been told you, that question. If a minus b, there is b minus a. If you multiply minus with a minus b, that is also b minus a. So we can write cos a minus sin a. We can write minus of sin a minus cos a divided by cos a into sin a upon sin a minus cos a. It's cancel. Then minus sin a, its whole square. Whole square is there. Then minus sin a, its whole square. Minus sin a upon cos a, its whole square. Minus sin a whole square is sin square a. Cos a its whole square is cos square a. If negative number is there also, negative and multiply with another negative, then it will be positive. So minus sin a its whole square sin square a upon cos square a. That result is also tan square a. That is the last one. Okay, it's proved. Both the side we have proved. This one equal to tan square a and this is also equal to tan square a. Thank you.